Today we're going to talk about number bases and how to work within number bases for our math team contest. So our default number system is base 10. So if I were to give you the number 324 in base 10, what we are essentially saying is that each place is a power of 10. So my 4, you could think of it as 4 times 10 to the 0, and then 2 times 10 to the first, and then 3 times 10 squared. Sometimes you'll see it written in this order. You might also see it written with them moved around. So that way it essentially matches the order of how we see them in their place values in this problem that I gave you. If no base is given, then the default base is 10. All right, what we're going to do is we're going to look through a couple different problems, and then from here we will build up our skill set. So first things first, when I see I want to convert 532 into base 6, we know that this is base 10. Even though it didn't say it, that again is our default base. Now there are a couple different ways that we can go through this. The fundamental way of doing this is to figure out the greatest power of 6 that we can divide into 532. So if we think about our powers of 6, first we have 6 to the 0, which is 1. We have 6 to the first, 6, 6 squared, 36, 6 to the third, which is 216. And then if I were to multiply that by 6 one more time, even without knowing what it is, I know that it's going to be bigger than 532. So I know that at most I'm going to have a 4-digit number. Now what I have to ask myself is how many 216s can go into 532? And 216 can go into 532 two times. So I'm essentially going to take 532 and subtract off 216 twice. You can also think of it like 532 minus 216 times 2, which is 432, which gives me 100. So I have fulfilled 2 of the 6 to the third. Now, with my remaining 100, I ask myself, how many 36s can I put in there? Well, I can definitely fit 2 36s. If I were to do 36 times 3, that would be greater than 100. So I can only fit 2 36s. So I'm going to subtract 72 here. And then I'm left with 28. And then now, again, I'm looking at how many 6s can I fit in here? Well, 6 goes into 28 4 times. So I'm going to subtract off 24, and then I'm left with 4. And then my last question is, how many 1s can I fit in here? I can fit in 4. So that will give me 2244, base 6. Now, another way that you can think through this is you can say, all right, well, what if I just did repeated long division? And that's another strategy. So if I were to do repeated long division, I'm going to take the number 532 and divide it by 6. So 6 goes into 53 8 times, leaving me with 52. Again, goes in 8 times, leaving me with a remainder of 4. Now I'm going to keep that 4. That 4 is going to come into play in a little bit, but for right now, I'm going to go ahead and keep dividing. So I'm going to do 88 divided by 6. And again, I have a remainder of 4. Keep going. So I have 14 divided by 6, remainder of 2, and then I go one more time, 2 divided by 6, 0 times, remainder of 2. Now, these values going from all the way to the end, back to the beginning, these values here are essentially my answers. So my answer is going to be 2, 2, 4, 4. And again, where I'm getting those numbers from are all of my remainders in reverse. Now, this trick can work nicely sometimes. However, it's really important that you understand the logic behind asking yourself how many of the base can I get in there. All right, now let's say I'm trying to go from one base into another. If you look this up online, you'll see a lot of different tricks that people use, but honestly, your best bet is to go from base 5 into base 10, and then from base 10 into base 7. So let's start by converting this base 5 into base 10. And I'm going to do that by looking at all of these place values as the powers of 5. Now, if I have a 5-digit number, then that means that my greatest power at the end is going to be my base to the 4th power. Or if I were to think of it like I had a number with n digits, then my last power would be the base to n minus 1. So here, because I have a 5-digit number, my leftmost value is going to be 3 times 5 to the power 4, and then 4 times 5 to the power 3, and then 0, and then 1. This is just 5 to the 1, and then 2 times 5 to the 0. And then now we can go ahead and we can actually figure this out. So we have 3 times 625 is going to give us 1875. This here will give us 500, 5 plus 2, and then all of that will add up to be 2,382 in base 10. And then now I want to take this base 10 and I want to turn it into my base 7. So again, I can look at this like the powers of 7, or I can do repeated division by 7. Either way that you want to do it, when we convert this into base 7, we are going to get 6642 base 7. And if you want to see the work for this, just pull up the keyed notes that I have. Actually, you know what? I can pull them up right here. So if you were to go ahead and do this, we can see that we have the strategy that I used here. I just did this repeated division by 7. All right, let's go on to the next problem. Oops, not that. Okay, so next problem here, we want to convert 245 base 9 into base 3. Now the reason why I chose this problem is because when we look at 9, 9 is equal to 3 squared. So what we can do here is we can expand this into we can expand it with base 9s. Okay, so expand as powers of 9, and then we can replace 9 with 3 squared. All right, so again, we have 3 places, which means that our highest power is going to be squared. So I have 2 times 9 squared plus 4 times 9 plus 5. And I'm going to go ahead and replace each of these 9s with a 3 squared. So now that will give me 2 times 3 to the 4th plus 4 times 3 squared plus 5. Now this is where things get a little interesting. Because I'm in base 3, I'm only allowed to have the digits of 0, 1, and 2. Because with base 3, as soon as I reach a 3, I carry over into the next digit or the next column. So what I need to do here is I need to take a look at all these values, this 4 and this 5 that happen to be not allowed in base 3, and think of a way that I can express them using powers of 3 or smaller digits. So this first part is fine. My 2 times 3 to the 4th, there's nothing wrong with that. However, this 4, well, that's a problem. But I can think of 4 as 1 plus 3, and that's times 3 to the 2nd. And I can think of this 5 as 1 times 3 plus 2. So again, we're looking at powers of 3, and then those numbers that are smaller than 3 being added on. So now if I simplify this, again, I'm looking to simplify this into a constant times a power of 3. I currently have 2 times 3 to the 4th plus this 3 and 3 squared make 1 times 3 cubed. And then when I distribute that, I just have 1 times 3 squared. And then right here I have 1 times 3 and then plus 2. And so those lead numbers give me all of my numbers for my base 3. So I have 2, 1, 1, 1, 2, base 3. All right, let's talk about addition and subtraction. Now, when we are doing addition and subtraction, it's very similar to regular addition and subtraction. The big difference is that you have to look at your base. So in this case, I'm in base 6, which means that I am only allowed to have the numbers 0 through 5. Whenever I reach a 6, I have to carry over to the next digit. So let's keep that in mind as we go ahead and do our arithmetic. So 1 plus 5 is 6, therefore I have to carry. 8 plus 1 is 9. So 9 is going to be a 6 on the left and then a 3 on the right. This is how I would write 9 in base 6. So that means I'm going to have the 3 here and I carry the 1 over. 1 plus 3 is 4, and since 4 is smaller than 6, I can leave it as it is. 5 plus 2 is 7. So again, I have to carry over the 6, so carry 1 over there, then I have 1 left over. We have 5 and we have 4. So this would be 4, 5, 1, 4, 3, 0, base 6. So again, whenever we get a number that is greater than 5, so 6 or greater, we have to say I want to carry 6 into the next column, and then what do I have left over?